Hello my dear children, this is my class 11th chemistry. The chapter going on is structure of atom. Now we are at the last of this chapter. Let us start the topic quantum number. Quantum number. Quantum number. These are the quantum number which are the solution of Schrödinger wave equation, that is quantum mechanical model. Quantum number tell us about the complete address of electron. Quantum number tell us the complete address of electron. Right? So now I am taking one example. What is meant by the address of the electron? Address of the electron. Electron belongs to which shell? There are 4 quantum number. Electron belongs to which shell? I am taking example like I want to know the address of a person and electron parallelly. Okay. Now there is one of the quantum number, that is a principal quantum number. There are the 4 quantum numbers. The first is principal. It is represented by N, azimuthal represented by L, and magnetic represented by M, and spin represented by S. Now students, I will write in detail later on. First of all, I want to share with you what is meant by the address. Person belongs to which city? Electron belongs to which shell? Right? City and the shell same and the same thing. You may call it orbit as well. Now after the city entrance, we go to the sectors. In the city there are the various sectors. Similar way, in the shell there are the various subshells. Shells with subshells and city with various sectors. In the sector there are the homes, and in subshell there are the orbitals. And where the electron is found, we discussed in the last lecture, that is a wave mechanical model. Electron motion around the nucleus is 3-dimensional, and the space where the electron probability is found maximum around the nucleus is called orbital. So electron is present in the 3D space around the nucleus, that is orbital. In a similar way, the person lives in the homes, right? And spin quantum number tell us only the direction. Either the electron moves clockwise or the electron moves anti-clockwise. So remember students, spin quantum number is an independent quantum number. It is not the solution of Schrödinger equation. So this type of question may asked in the competitive exam. All the competitive type of questions and the other details of the numericals even I will take in my next lectures, because first of all I am going to complete the basics of the chapter. So there are the 4 quantum number. Now I am writing in detail. You may write along with me. The first is principal quantum number. Principal represented by N. Second is azimuthal, A-Z-I-M-U-T-H-U-L. Azimuthal represented by L. Third is magnetic quantum number represented by M. And the fourth is spin quantum number. It is just independent. It is not the solution of the wave equation. It tells us only the direction. So one by one I am taking in detail with questions. Now first of all, I think now it's clear for you what is meant by the address. A person belongs to which city, and in the city which sector, and after the sector entrance, what is the house number, that is the orbital. City, sector, homes. Same way in the atom there is a shell, subshell and orbitals. Now I am taking right down. The first is principal quantum number. Principal quantum number tell us about that electron present in which shell. 1, 2, 3, 4. It's a code number. If the electron present in 1, it belongs to K shell, it belongs to L, M, N, O, P and so on. So first point is principal quantum number tell us electron present in which shell. Write down. Second information given by this quantum number, that this quantum number tell us about the energy of each shell, and you know how to calculate energy of electron present in various shell by applying the formula minus 2.18 into 10 raised to power minus 18 into Z square by N square. This is in joules. What is a Z? So many times I discussed Z is the atomic number of those species which have single electron, like H, like helium plus, lithium 2 plus and beryllium 3 plus, and N is the number of shell 1, 2, 3, 4, K, L, M, N. So this comes, this minus 2.18 into 10 raised to power minus 18 is a constant value of minus 2 pi square ME4. This is the, pi is a constant, M is the mass of electron constant, E is the charge of electron is constant. So minus 2 pi square ME4 into Z square by N square. So this quantum number tell us about the energy of each shell, or you can say energy of the electrons present in any of the shell. Third information given by principal quantum number, this quantum number tell us about the size of atom. Size. How is it possible to determine the size by principal quantum number? To determine the size, we will calculate the energy first. The answer is when the energy, let the energy of the first shell is minus 2.18 into 10 raised to power minus 18 joule, because of N scale is 1. This is energy of the first shell. If the electron is present in the first shell, then the electron has energy this much. If electron is present in the second shell, then the energy of hydrogen atom I am taking minus 2.18 into 10 to the power minus 18 divided by 4. That means the energy increases. Now third shell, it is minus 2.18 into 10 to the power minus 18 by N square. N square is 3 square 9. So after calculation you came to know in which case energy is minimum. You can know after calculation, or you can see the energy is minimum and minimum in the first shell. When the energy is minimum, that means electron is present very close to the nucleus, and when electron is present very close to the nucleus, the atomic size is small. When the energy become more and more, I am taking just one example. Energy of the first shell is very less. When electron is present in the first shell, energy is minimum. So that means the first shell, this means if electron is present in the first shell, energy is minimum and the size of the atom is very small. I am taking one example. Let it is a nucleus, and let it is electron is very far away. Now students, when electron is very much far away, there is no attraction and no repulsion between nucleus and the electron. But when the electron come near to the nucleus, now electrons start coming near to the nucleus, you know there is an attraction takes place, plus and minus electrostatic force of attraction takes place, and due to attraction energy released. Electron come more and more near to the nucleus, more and more attraction takes place, more and more energy released. Electron come again very near to the nucleus, same, more and more attraction takes place, more and more energy released. The energy release is too much that it become less than zero. This means energy become negative. That's the reason electronic energy of any of the shell, either you calculate the energy of 5th, 6th, 7th shell, because there is a formula minus 2.18 into 10 to the power minus 18 into Z square by N square. In the formula there is a negative. Negative sign indicates electronic energy is always negative, and this sign tells us that an electron is present very near to the nucleus. Either the electron is present in the 5th shell. The 5th shell is also very close to the nucleus. I think it's very much understandable. Now again listen, why electronic energy is always negative? Answer is because This negative energy signify that electron is present very, very close to the nucleus. Okay, because when electron is far away, no attraction, no repulsion, energy of the electron is taken 0. But when electron coming near and near to the nucleus, attraction takes place, energy released and released and released. It's so much released, so much come closer that energy become less than 0 and will become negative. So this is the answer, that electronic energy is always negative. So how will you calculate the size of the atom? What you will do? You will find the energy of the electron. If the energy of the electron is coming more as compared to the other atom, the atom where the energy of the electron is coming more, whose size is bigger than whose energy of the electron, where the energy of the electron is coming less. Lesser energy means electron is present very near to the nucleus and the size of the atom is small. The fourth information given by principal quantum number, this quantum number tells us the main line of the spectral, that is if n is equal to 1, it's a Lyman series. If n is equal to 2, Balmer series, Paston and bracket Puffund. 1, 2, 3, 4 we have discussed in the Bohr spectra. So this principal quantum number tells us about the main spectral line, Lyman, Balmer, Paston, bracket and Puffund, N1, N2, N3, N4. So this completed your first quantum number, that is the principal quantum number. I am again repeating, principal quantum number is like the city of a person. Principal quantum number tells us electron is present in which shell, which orbit, which city. So this quantum number tells us the energy of the electron. This quantum will tell us about the size of the atom and the main line of the spectrum. Second quantum number, write down, is a azimuthal quantum number. Azimuthal quantum number is also known as secondary quantum number. Secondary, it is represented by L. This quantum number tells us, it is also you can write ML on the subscript L, either you simply write L. So this quantum number, now I am taking in detail about this quantum number. This quantum number tells us that electron present in which subshell. Okay, now I am making one table, let n is equal to 1. When n is equal to 1, then this is principal quantum number and the second is of azimuthal. This is your L. L is what? L is a value which varies from 0 to n minus 1. Okay, now I am taking if n is equal to 1, I am writing just n. Now if n is equal to 1, then what is the value of L? L is equal to n minus 1. So it is 1 minus 1. N is 1, then you put 1, 1 minus 1, 0. That means your L is 1. If n is 1, your L is 0. 1 minus 1 is 0 and 0 to 0, one figure. If n is equal to 2, your L is 2 minus 1, 1. So 0 to 1. So L is 0 as well as L is 1. You go on writing after half an hour, it become a very simple topic for you. You go on writing and keep mental attention on the blackboard what I am taking. Now if n is equal to 3, then 3 minus 1, 2. 3 minus 1, 2. So 0 to 2. L is 0, L is 1 and L is 2. Okay. Now if n is equal to 4. If n is equal to 4, it's 4 minus 1, 3. So 0 to 3. So L is equal to 0, L is equal to 1, L is equal to 2 and L is equal to 3. Now this is your K shell when N1 that we have discussed already, repeating, N2L, N3M, N4N. Now let us give the names. If L is 0, it's called small letter S. If L is 1, it's called small letter P. L is 2, small letter D. L is 3, small letter F. So it is your SP. So it is your SPD and your SPDF. SPDF. S for sharp. These are the spectral term. P for principal. D for diffused. and F for fundamental, diffused fundamental. So these are the abbreviation taken from the spectral terms. Now let us start this azimuthal quantum number in detail. This is the way I have calculated. Have you noticed the number of the subshell? The number of the subshell is always equal to the number of the shell. Here you can check. First, it is one subshell carrying, 2 it is 2, so it is 2 subshell carrying S and P, 3 it is 3, 1, 2, 3 SPD, it is carrying 3 subshell, 4, 1, 2, 3, 4. So always remember, you may write the number of the subshell, number, how many numbers, how many subshells are there, how many sectors in a city, 4 sectors in a city, 3 sectors in a city, 2 sectors in a city, and 1 sector, depend upon the number of the city. If the number of the city is 1, sector is only 1, very small city. If the number of the city is 2, sectors are 2. Number is 3 of the city, sectors are 3. It's a shell. Now coming to the electronic world, these are the shells of electron, these are the subshells of electron. S, P, D, F are the subshell. L is 0, S, L is 1, P, L is 2, D, L is F, L is 3, F. So azimuthal quantum number, first information given that it tells us electron belongs to which subshell, right? And other it tells us, second I'm taking, now this is the information, first information given by azimuthal quantum number, that electron belongs to which subshell. If I'm writing 3p, I'm asking a question, what is a shell of electron? You will say n is equal to 3. I will say what is a subshell of electron, because with a p written, you will write L is equal to 1, address it is. Okay, if I'm going to write 4f, 4f is the address of electron. What is a shell of electron? 4. And what is a subshell? 4 SPDF 0, 1, 2, 3 F for 3, L is 3. This is the address. Electron belongs to 4th shell and 3rd subshell. So this is your first information. Second information. Second. Now this quantum will tell us the energy of each subshell. S orbit, S subshell is present very close to the nucleus, highly penetrated towards the nucleus. So remember, S has a less energy than P, then D and F. S is more penetrated towards nucleus. That means the electrons present in the S subshells, they are very close to the nucleus. That means it has very close, means energy is less. So S subshell has less energy than P, than D and F. Penetration power, energy level, S subshell has less energy because S subshell is highly penetrated towards the nucleus. The third information. The third information given by the azimuthal quantum number is that this quantum will tell us that the fine line of the spectrum, fine lines, that is it's falling from that we have discussed on that day, that it is n is equal to 1, n is equal to 2, and when it was fine lines 2 to 1, 3 to 1, 4 to 1. So main line, this is a main line, this tell us by the this information given by the principal quantum number, and the fine lines, these are the fine lines. There are many of the lines, this information is given by the azimuthal quantum number. This we will take in the questions. Now after that, so number 3, this quantum number shape of the subshell. S has a spherical shape. I told you on the in my previous lecture, this quantum will tell us the shape of the subshell. Even it's called that is symmetrical, spherical, symmetrical, double dumbbell, and F subshell have a very complex shape. Now again listen, I've discussed principal and azimuthal. Parallelly I'm going. Principal quantum will tell us about the shell, and in the shell there is present subshell. This information given by azimuthal. main line of the spectral main line, principal fine lines by that your azimuthal, and energy of size of the atom, energy of the electron present in each shell by principal, shape of the subshell, energy of the subshell given by that is azimuthal. Now your turn is of third quantum number. It's a magnetic quantum number. Magnetic quantum number. Magnetic quantum number, it tells us about the orientation of electron. Orientation. Each orientation belongs to orbital. Write down. Number of orientation is equal to number of orbitals. Magnetic quantum number tells us about the orientations of electron. I am taking in detail what is meant by this. Now let us make a table now. Again, just expand the table little. Now I am taking your 3 columns now. Right? This is your N is 1. Okay, now second is your M. This is your third principal, azimuthal magnetic. N is 1, and L is 0. Now what is M? What formula you will apply to calculate M? Either you apply the formula M is equal to 2L plus 1, M is equal to 2L plus 1, or you apply the simple formula minus L to plus L, minus L to plus L including 0, including 0. Okay, let us start. If N is 1, L is 0. So what's the value? 2 into 0, 0 plus 1, 1. That means your S sub S, if the electron present in the S subshell, M is coming 1, that is orientation is coming 1. This means electron is rotating around the nucleus just in a one way, spherically symmetrical. So S subshell has only one orbital, that is your M will come 0. Just wait. N is 2. When N is 2, your L will also have your 2 values. L is 0, starting always from 0, because L is N minus N. It values varies from 0 to N minus 1. We discussed. So L is 0 as well as 1. Now it becomes very easy for you by taking this example. If L is 0, it's called S subshell. Electron is present in S subshell. If L is 1, electron is present in P subshell. Let us check now what is the M. M. It is 0 because L is 0, M is 0 always. Now what is L is 1? When L is 1, you put here 2 into 1, 2, 2 plus 1, 3. This means your P electron revolve around the nucleus in a 3 ways. It has 3 orientation, 3 axes, X, Y, Z. Okay, so I'm writing minus L to plus L, minus 1, 0, plus 1. Put comma in between. Minus L to plus L, minus L to plus L, that including 0, minus 1, 0, plus 1, 3 orientation. E electron will revolve around the nucleus in a 3 ways. I think you remember it's x-axis, y-axis and z-axis. Again, I'm taking now example N3. And when in the 3, L is 0, L is 1, 3 values. Okay, 3 and 3, and L is 0, your M is 0. L is 1, your M is minus 1, 0 plus 1. L is 3, go from minus L to plus L. Minus 3, L is 2. So M is minus 2, minus 1, 0, plus 1 and plus 2, 5 values. Now you can check 2 into 2, 4, 4 plus 1, 5. This means that D electron, this is S electron, this is P electron and this is D electron. D electron will revolve around the nucleus in a 5 ways. It has 5 orientation, it has 5 orbitals. Do you remember the names? That is DXY, DYZ, DZX, same. So I'm going to write minus 1 means PX or PY or PY, plus 1 again means PX or PY, but 0 for PZ. You write please. If I'm taking one question, 2pz. What is the N? N is 2. What is the L for P? L is 1. And what is the M for Z? M is 0. Check pz. M is 0. Okay, so 2pz. Minus 2, it is dxy. And your plus this 0 for dz square. 0 for dz square. Minus 1 for dzx yz, plus 1 for dyz, plus 2 for dx square minus y square. If I'm going to write, it is your 3dz square. I'm writing here 3dz square. What is the address? N is 3 because 3 means shell. L, D it is SPD, S for 0, P for 1, D for 2. What is the M? Z square. D Z square M is 0. I think it's clear now. But if there is written X, Y, then just your rest value will remain same. N is 3, L is 2, but M is no, it is your, you may write or, it is your minus 2 or plus 2, plus minus 2. Always remember this minus 2 and plus 2. These two values are for x, y, and minus 1 plus 1 for z, x, z or y, z. Now I am taking this all about. So your principal magnetic, I am taking in detail now. What is the magnetic quantum number? Magnetic quantum number tells us about the orientation of electron. Orientation means electron revolve around the nucleus. In which manner S electron moves around the nucleus in just one way, that is spherically symmetrical. It has only one orientation. But P electron, P, moves around the nucleus in 3 ways, that is x-axis, y and z. D electron moves around the nucleus in 5 ways. That ways and shapes we have discussed already. Now I am taking N is equal to 4. I write down when N is equal to 4. Then what is your L? Your L is 0, 1, 2 as well as 3. L is 0, 1, 2, 3. 4 means 4 subshells. When L is 0, your M is 0. Minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1 and plus 2. But when it is minus 3, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 7. Now students, in the next topic, this will work. How it will work? When you will draw the shape of the orbital in the next topic, you will designate the orbital by a single square. This is S single. For calculation, we will do something in the next topic. P, make 3 boxes. Px, Py and Pz. 3. D, all have the same energy. 1, 2, 3, 4, 5. One for dxy, other for dyz, dzx, dx square minus y square, and the last is dz square. And when F come, this is S, this is P, and this is D. Make S 1, make P 3, and make D 5 at one time. And for, I'm taking F now. F, shape of the F orbital, and the names are complex, so that are not in your syllabus. So 1, 2, 3, 4, 5, 6 and 7. So always draw 7 boxes when F orbital comes. So magnetic quantum will tell us electron present in which orbital. It is rotating in which direction. X-axis, Y-axis or Z-axis, between axis, where it is. Now what magnetic quantum will tell us? Magnetic quantum will tell us the orientation of electron. Each orientation belongs to orbital. Magnetic quantum will tell us about the, that is your, why the spectral line is split when placed in a magnetic field, that is called Zeeman effect. Spectral line is split. Spectral line is split when placed in a electric field, Stark effect, main line of the spectra, principal, fine lines of the spectra, azimuthal, spectral lines splitting in magnetic field and in electric field, Zeeman and Stark by magnetic. So this is your principal, azimuthal and magnetic. And what would spin? Spin quantum number is represented by ms or simply s. Spinning electron around the nucleus is just behave like a magnet. So it shows magnetic moment. Now how to calculate spin magnetic moment we will take in the numericals. Just write down, if electron rotate clockwise and anti-clockwise, it is shown by two types of spin, plus half and minus half. Clockwise plus half, anti-clockwise minus half. Electron moves around the nucleus clockwise and anti-clockwise. It has two values, plus half and minus half. Independent it just tell us the direction of the electron. Electron revolve around the nucleus in which way, clockwise or anti-clockwise. Now I'm taking one question. I'm writing n is equal to 4, L is equal to 4, M is equal to plus 3, S is equal to plus half. Write down first part. Second is n is equal to 3, L is equal to 0, M is equal to 0, S is equal to 0. Third part, n is equal to 4, L is equal to 1, M is equal to minus 4 and S is equal to minus half. Fourth part, n is equal to 4, you can take, L is equal to 1, M is equal to plus 1, S is equal to plus 1. So these are the addresses I have written, address of electron. The question is, which quantum number address, that is address, which quantum set is right and wrong? Always remember students, whatever the value of n, no other quantum number has the same value as that of n. Now this quantum number is wrong because L and n, L equalizes to n value. L never be equal to and greater than the value of n. Very simple answer. Now this is your wrong. Second, yes, n3, L is 0 possible, M 0 possible, but S 0 never possible. So this set is wrong because spin quantum number either is plus half or minus half. Okay, now n is 4, L is 1, but M is minus 4. Maybe it is minus, but it is a 4. Okay, this is again wrong. Now fourth is n is 4, L is 1, M is plus 1, and this is the only which is right. So in this way you can identify. So remember, no other quantum number has the same value as that of n has. Now I'm taking your question. Now I'm writing n is equal to 5. Write the set of quantum numbers just given and 5. And 5 means L are also 5. Starting from 0, 1, 2, 3 and 4. 1, 2, 3, 4, 5. What is M? M is 0, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1, plus 2. Same way, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, minus 4, 2, plus 4. Right. Now I'm taking next question. Designate it. If I write n is equal to 4, L is equal to 1, what does it mean? Answer is, it means electron is present in 4p. If I'm writing n is equal to 4, L is equal to 2, this means electron is present in 4d. L2 means d. Is it okay? If I'm writing n is 5 and L is 4, it is your 5g, because 0, L for 0, 1, 2, 3, 4. Now it's S, P, D, F, G. If L is 4, your L is G. So 5G it is. Now if anybody asks you whether your 1P exists, is 1P address is right? N is 1, L is 1. No, this address is wrong No other quantum number has the same value as that of n has. So this is all about your quantum numbers. Your one topic just left, that is filling of electron in these orbitals. After that, there are plenty of questions related to that topic. After completion of the chapter, we will take those questions. So those questions will be very much important. You will note down all the questions. So this is today's lecture. So we have completed almost a chapter, just one lecture left, that is filling of electron in orbital electronic configuration. Thank you.